Hello, good morning. This is Naz from NB Network Lessons. Hope everyone's doing okay and in high spirits. This is physics lesson number 35. Date today is August 30th, 2024, and we are going to discuss Earth's gravitation motion in free fall. Everybody knows that if I drop this pen from right here, okay, it's going to come down due to gravitational pull by Earth, right? Right here. It's coming down. It comes down at 9.8 meter per second square acceleration. So, in other words, if I drop this every second, the velocity is increasing 9.8 meter per second. Okay. So, this was basically, you know, figured out by Isaac Newton, and then later on, Albert Einstein, one of the great scientists, they basically elaborated and added more to it. There's so much fascination in this. um, I mean, because later on, they basically discovered something which is called space-time curvature. Okay, how gravity acts in space-time. I'll touch base on that. I'll discuss that also, not in this lesson, but in my upcoming lesson. But it's mind-blowing. It's fascinating. If you love physics, if you love science, don't miss that out. I learned it and I am so fascinated by it, and I am eager to share that with you all. Okay. But anyway, so if I take this bottle, this is heavy. I think it's about probably, I don't know, maybe a pound. Okay. If I drop this, this also drops at the same rate, 9.8 meter per second square acceleration every second. Okay. So if I drop this, I say maybe it took about half a second. If I drop this marker, which is much lighter than that bottle, I say it take about same time. So anything which I drop in air travels to my Earth at 9.8 meter per second square acceleration. Clarity, it is in every second it's accelerating 9.8 meter per second square. Okay, so every second your velocity is increasing 9.8 meter per second square. When I was studying physics, about, I don't know, maybe 25, 30 years ago, they used to have 32 feet per second square acceleration. So in those days, foot pound system was popular. But later on, we decided that we're going to dump FPS and bring in meter, kilograms, and so forth. But anyways, that was just a small tangent. So let's look at motion due to free fall. So I said gravity, okay, gravity by which Earth pulls something which is dropped is 9.8 meters per second square. Okay, that's on Earth. Okay, what about if you go up into space? What about if you go up in the moon? So the gravity at moon is 1.62 meters per second square. That's on moon. Okay. Now, so in other words, it's 6 times less than the gravity of moon. So in other words, if you go up on the moon, you will weigh, let's say, 6 times less. Okay, if you go on the moon. Um, you know, I've seen where documentary films about the, you know, moon, where we have seen the scientists or the space people wearing heavy dresses on them. Why do they do that? Because if they don't and they jump or walk, they might just, go up in the air, and then who knows, they might get lost. So they wear heavy space suits to keep them on the moon's surface. rather than you still see them when they're walking around. There's a little bit of jump. Okay, that's because there is less gravity, less pull. Moon is pulling objects with 1.62 meter per second square. Earth is pulling them at 9.8 meter per second square. Let me ask you this. What about sun? Gravity on sun. Let me put that in red. So gravity on sun. Any guesses? How much is the gravity on sun? Well, it is 274 meters per second square. That's on the sun. Okay, so it's a lot more. That's why when we get into the space curvature, we'll talk about star rings around the sun, how they are pulled, how they affect light, which we see on the Earth. Especially when we have the eclipse, when the lunar eclipse takes place, when the moon comes in between Earth and sun, how light is reflected to us. I'll talk about that, I promise you, because I'm fascinated by it and I want you guys to be fascinated by it, that too. So now I ask you, I said just that, when I drop this and when I drop this bottle, which I showed you earlier, they fall at 9.8 meter per second square. So you can basically say, Nas, that's not true. What about if I drop a hair? What about I drop a piece of feather? It's not coming down at 9.8 meter per second square. Yes, you are correct. It is not. But why? Because of the air, because of the friction of the air. They have done experiments where they have taken huge jars, okay, and sucked out the air out of them, okay, and then dropped two objects. One was, I don't know, maybe a marker, and the other was feather. Both of them fell down at the same time, same rate, with 9.8 meter per second square. Okay, so that's the answer. Why a feather, why a piece of hair is not falling down? It's kind of like waving the air. That's because of the air friction, because the air is basically resisting that. But if you take the air out of the picture, then they fall at the same time. Uh, let's see. I want to discuss one more thing. Now, on the Earth, okay, let's say this is Earth right here, okay, Earth, and let me say, I am standing right here. This is me standing right here, okay, and I'll just put my name, Nas, and the gravity is 9.8 meter per second square, okay. So Nas decides to go on to one of the highest mountains in the world. The name which comes to my mind is K2 Mountain, which is basically in northern Pakistan on the border of China and Pakistan. And the reason it came to my mind was because when I used to smoke, there was a cigarette by name of K2, and I used to smoke that. So that's why the name just kind of resonated and came to my mind. So when Nas says there is a mountain, K2 Mountain, okay, K2 Mountain, which is about 28,000 feet high, okay. So Nas, I never went up to K2. I'm just making it up. So Nas went up to top of this K2 mountain, right? Now let me ask you this. What is my gravitation when I went up there? So at that height, your gravitation pull by Earth is 9.78 meters per second square. So you see, it didn't make any difference. There's not a whole lot of difference. When I'm at Earth, it's 9.8 meters per second square. But when I got onto the top of the mountain, K2 mountain, the gravitation pull is 9.78 meter per second square. So I just kind of wanted to, in this particular lesson, I just kind of wanted you to introduce you with gravitation and free fall, concept of free fall. I'm going to come back and we're going to talk more about it. Like I said, we're going to dive into space curvature, which is a fascinating theory by Albert Einstein, one of the greatest scientists in the world. Thank you so much for watching. I really appreciate it. Please share this lecture with as many folks as you can and go ahead and give me a like. Thank you so much.